Okay, now we'll discuss about the rabbit and the Fibonacci numbers in the recurrence theory. Now suppose that the Fn denotes the number of pairs of rabbits after n months in a hole. Okay, there is a hole in which there are a lot of pairs of rabbits out there, and the Fn denote the number of pairs of rabbits after n months. Consequently, the sequence Fn satisfies the recurrence relation. This is from observation. Okay, so the recurrence relation connected to this rabbits and rabbits, where Fn denotes the number of pairs of rabbits, is given by Fn equals Fn minus 1 plus Fn minus 2. The corresponding sequence, recurrence sequence, is given by Fn. Fn denotes the corresponding sequence. And you can recall what is a recurrence sequence is and what is a recurrence relation is. This recurrence relations makes this sequence, or this sequence satisfies this recurrence relations. For n is greater than or equal to 3, with f1 is equal to 1 and f2 equals 3. So for other values, the 3, 4, 5, 6, that will satisfy this. And this is what we say Fibonacci numbers we say. Sometimes you'll have the problem like that. In that particular case, we must use the Fibonacci number. Now let us have one problem here. Find the recurrence relation for the number of a rabbit string of length n that do not have two consecutive zeros. Here you must understand that. Find the recurrence relation for the number of bits of string of length n that do not have two consequent zeros. Second question, how many such bit strings are there of length 5? Now the relation is given by this, because string relations, I mean the recurrence relations given by this one, an equals an minus 1 plus an minus 2 for n is greater than or equals 3. This is what string recurrence relation. The initial condition are a1 is equal to 2 for ending element will be 0 and 1. Am I correct? So when the initial condition are a1 equals 2, when the ending numbers are 0 and 1. So if that is the case, the value would be a1 is equal to 2. Now L2 equals 3 for ending the numbers 0, 1, 1, 0 and 1, 1. Because you must understand that find the recurrence relation for the number of bits string of length n that do not have two consecutive zeros. So in this particular case, you don't have two consecutive zeros, so a1 is equal to 2. In a2, you should not have two consecutive zeros here, therefore chances are 0, 1, 1, 0, 1, 1. So these are the chances of no consecutive zeros there. So now let us have B to find such a string with 5 length. The length should be 5. So A3 would be equal to A2 plus A1 by using this particular relation, and you will have this particular value. A3 equals A2 plus A1 equals 3 plus 2 equals 5. A4 equals A3 plus A2 by using this particular relation. A4 is equal to A3 plus A2, and A4 equals A3 plus A2. A3 already we know 5 and A2 we know 3. Add both of them, you will get 8. Now what about A5? That's what we are interested in. Am I correct? So A4 plus A3, 8 plus 5 equals 13. So 13 strings are there of length of 5 that do not have two consecutive zeros. So this is one of the problem, very important problem, okay, that uses the Fibonacci or rabbits recurrence relations. That's what we have to understand. Now look at that. This is another chapter. We will discuss that later.